This question really hinges on the idea of a tree diagram, and that is to say, look, we're going to throw a dice. One, two. There are six possibilities. I could get 1, 2, 3, 4, 5, 6, and then I need to draw on each single number a second roll, and there are going to be six possibilities for that. So it gets very messy very quickly. But let's say me getting 1 again, and then on the third one, okay, I'm only drawing part of the tree diagram. What if I get 1 again? Well, every time there's a 1/6 probability. And what we do on tree diagrams is we multiply these probabilities together. So the probability of getting 1, probability of 1, is actually 1/6 times 1/6 times 1/6, or 1/6 cubed. But that's not actually quite what the question's asking, but it's part of the main, nearly there with it, because I got to remember that I'm just interested in the same number. So if that's the probability of getting 1, then the probability of 2 is exactly the same. It's also 1/6 cubed, and it's the same for 3, 4, 5, or 6. So if I add all those together, that will give me the answer, and it's actually be 6 lots of 1/6 cubed, which is actually 1/36. If you figure that out, I'll show you in the calculator how you might do it. Actually, the 6 and the 1/6 partially cancel, and you're just left to do 1/6 squared, which is 1/6 times 1/6, which is 1/36. But let me just convince you if you're not convinced. 1. Okay, 1/36. And I would leave the answer like that. Just very quickly, like another way you could think about it is you could think about the fact that it doesn't actually matter what number you get the first time round. Like I can get any of the numbers, so there's almost like a 6/6 probability, like it doesn't matter. But after I've picked the first number, I then have got a 1 in 6 chance of getting the same number the second time round, and then again that time round. So this is a different way of thinking about it, moving a bit away from the tree diagram. You may or may not like that idea. It can come in useful. It's like, it's kind of like it's the number of ways that we're interested in divided by the total number of ways, and we're kind of incorporating all the same number into just a single calculation. But in the end, it is equivalent to what we did before.